All right, we're about to do some problems that involve reducing radicals. The radicals we're going to reduce are square roots, but I have some cube roots on this page as well, just to remind you for future chapters. So here we go. So some of you like to use the birthday cake method, and I think you do 24 and then you kind of go like this. I'm not quite sure how that one works because I don't usually do that, but what I just do is I start breaking up the number. Like I see 24 and I say to myself, well, I know 24 has like 6 times 4. And then remember, you have to break it down to its prime factors. And so 6 and 4 both have things that multiply to them, so they still have more ways to go. So 6 is 3 times 2, and 4 is 2 times 2. So when I'm done here, this is a square root. Remember, if it's a square root, you don't have to put a little 2 right there. It's already just assumed there. And so now you need to look for pairs. So when I look here, I notice I have a pair of 2's. And so that means that I can bring a 2 out, because a pair of 2's means 1 2 comes out. Well, left inside the radical, the 3 and the 2 that I didn't use on my list, I have to put them back together. So 3 times 2 is 6 to go back in there. All right. So with number 2, example 2, 96. So not quite sure about 96. I know it's an even number, so I'm just going to say it divides by 2. So you might, you have your calculator with you. So 96 divided by 2. You would do that. And you say, okay, it's 48. Now it's down to a more manageable number. So 48. This time I'm looking for triples because it is a cube root. So 48, let's see, 6 times 8. 6 is 3 times 2. And 8 is 4 times 2. But then I have 4 is 2 times 2. So remember, I'm looking for triples. I have lots of 2's here. So let's see if I can get triple 2. One there, one there, one there. Oopsie. And then not enough for anything else. All right, so I'm going to bring out a 2 again, just like the last problem. And then inside the cube root, I have to put that little 3 right there. I have a 3 and a 2 and a 2. So 3 times 2 is 6. 6 times 2 is 18. And that will be it. All right, for number 3, example 3. There's a negative 7 sitting out front, so whatever I bring out, I'm going to multiply by that negative 7. So let's start with my 80. I don't know, 8 times 10, how about? 8 is 4 times 2, and 4 is 2 times 2. This 10 back here is 5 times 2. So I'm looking for pairs again. So I do have a pair of 2's here, and another pair of 2's there. So I have 2 pairs of 2's. So 2 times 2 is 4. I'm bringing out a 4, and there's already a negative 7 out there. So that 4 that I'm bringing out is going to have to multiply with a negative 7, so that'd be negative 28. And you see I have this one lonely 5 that I never touched, so I have a square root of 5 left. All right, for example 4, 243. So 243, I mean, it's an odd number, so maybe I'll try to divide by 3. So, some of those things you don't know off the top of your head. So 243 divided by 3. Okay, 81, there, that worked. So 81 times 3. 81 I know is 9 times 9, and then I have 3, 3, and another 3, 3. So I am looking for a square root, so I'm looking for pairs again. So I have a pair of 3's and another pair of 3's. Oopsie. So 3 times 3 coming out is 9, and there's a 3 left inside. So 9 square root of 3. All right, and I forgot to box this answer. All right, the last one over here is another cube root. There's a 10 sitting outside, so if I bring anything out, I will multiply it by 10. So 54, let's see, 54 is 9 times 6, 9 is 3 and 3, and 6 is 3 and 2. All right, so it looks like I have 3 3's. So there's my 3's. I'm going to bring 1 3 out. So 3 times a 10 out there is 30. Put my radical with a 2 left inside, and you have to put the little cube root right there. All right, so these problems down here, these 12 problems are for you to do and turn in.